Hi, we're here at George Mason University's Potomac Science Center, where myself and many of my colleagues are working on a marine debris prevention project. And one of the things that we're focused on is how do microplastics pass up the food chain? I mean, for example, if a bottle rolls out of a car, like perhaps this hand sanitizer I found on the ground, it bounces along the asphalt and it gets scratched, little bits of plastics fall off. And when it rains, they can wash into a retention pond, such as what you see here. This retention pond is put here, mandated by state erosion and sediment control law. Anytime you have an area that has a lot of hard, impervious surface, like asphalt, like roofs, like driveways that rain doesn't go through, retention ponds are put nearby, so when it rains, the stormwater flows off of that into the pond. It is retained there before it goes over the spillway into the next body of water. And what we find in our retention pond is it gets a lot of plastic bottles and floating debris from the nearby neighborhood. Now, does it impact wildlife? We know we've got a bunch of turtle species here, like at least 4 species of turtle. We've got great blue herons, green herons, barn swallows nest under this pond dock. And what we're looking at today is how do these little bits of microplastic impact possibly the smaller organisms like plankton. There's a lot of plankton out here during all times of the year, but we don't know, do they eat it? Does it stick to them? I don't know. But what we're gonna do today is we're gonna collect some plankton with a plankton net. This is Chelsea Gray, and she works on basking sharks. She's a graduate student at George Mason in the Environmental Science and Policy Department. And she works on basking sharks, which are some of the coolest sharks ever because they do what?
They eat plankton.
Yeah, and not people, and not meat. So it's real interesting. She's gonna demonstrate how we collect plankton.
Yeah, so this is a 44 micron net. If you look up close, you can see that it's a really, really fine mesh, and that's what's gonna catch those microscopic zooplankton for us. In the net, we have a flow meter. We're not gonna be using the flow meter today, but if we were towing it on a boat, the flow meter spins and tells you how much water passes through the net. And then at the very base of the net, we have the cod end, and that's what's gonna collect all the zooplankton kind of at the bottom, and that's how we're gonna be able to dump them into our collection jar. So when we're sampling in the pond, we just carefully lower the net in, and the cod end is kind of heavy, so it's gonna weight it down, and this is what we call a vertical tow. So we lower it down, and we pull the net up, and then we're gonna do that a couple of times so that we're catching lots of different zooplankton. And the reason we're doing a vertical tow is that zooplankton are found all throughout the water column. Especially at this time of day, they're gonna be a little bit deeper in the water column. They do what we call diel vertical migration. So they swim up the water column at night, and then during the day, they go back down, and that's because a lot of their predators are visual hunters. So during the day, they wanna be kind of where it's a little bit darker, where they can't be seen as well. So when we lift it up, we wanna shake out some of that water. And then what we're gonna do is we're gonna take our squirt bottle. We're just gonna kind of rinse some of those zooplankton down into the cod end. Let's see, did we catch anything? So if you take a look inside, you'll be able to see a lot of little zooplankton in there.
How do you know they're zooplankton?
Well, I won't be sure until I look under the microscope, but having looked at a lot of zooplankton caught in a zooplankton net and then having verified under the microscope, I can just sort of tell that definitely there's some zooplankton in there. Plus, if you look real close and you hold it very steady, you can see that they're moving around. So in this case, it's actually a little bit easier to see their shadows than it is to see the actual zooplankton themselves because they're kind of clear, but you can see their shadows as they zip around in the water.
And how did the zooplankton get into this pond if this pond was basically just built as a retention pond and also used when this used to be a golf course? How did the plankton get here?
Well, you know, as they say in Jurassic Park, life finds a way. You know, there's a couple of different ways that zooplankton could get in, a multitude of ways really, but zooplankton, they hatch from eggs. So their eggs can travel, since they're microscopic, right? Their eggs are very small. Their eggs could easily travel through any kind of water that's leaking in from the aquaquan right over there. They might be able to stick to like the feet of, birds, or to like turtle shells, or in leaves and debris that get washed in from the river to here. So we pour the zooplankton in the jar, and then see they stick to the edge. So we've got to rinse them off.
Now, do we know if any zooplankton, is it known whether or not they eat microplastics?
It's not super clear, but there's some data that indicates that they very well might be consuming microplastics. And if they are not consuming microplastics, there's been in-lab experiments where microplastics have stuck to the hard shell of zooplankton. So zooplankton have what we call a carapace. It's almost like a crab shell, just very, very microscopic, and plastics can stick to it and impede their ability to swim. When it comes to really fine microplastics, because a lot of zooplankton are non-discriminant feeders, so what that means is they just sort of collect, they sort of push microalgae and phytoplankton into them. They can't really distinguish between microplastics and algae, and it does look like they do consume them on the occasion. But as Dr. Smith already said, I research basking sharks. A big concern about microplastics and zooplankton is that microplastics and zooplankton are often about the same size. So a basking shark, which is a filter feeder, it takes its big giant mouth, swims through the water, collects a ton of zooplankton. It can't distinguish between zooplankton or microplastics. So it'll consume both of those during one feeding session.
Do you think any of the turtles or the small fish in this pond eat microplastics?
Yeah, absolutely. There's a lot of evidence that birds will consume plastics, either microplastics or what we call macroplastics, so larger plastics. Definitely turtles could mistake, pieces of plastic for fish, for, small bits of food. Birds definitely do the same.
All right, so we just came in from the pond with our plankton sample. And what we're going to do with that is we're going to put it under our microscope and add to it a little bit of glitter. Glitter is a common microplastic that is used all over the place in art projects. People throw it in the air for celebrations, but sadly when it rains, it washes down on hard surfaces and it gets ground up and it enters our waterways. And we were wondering, does it impact our zooplankton? And Chelsea's going to look at the microscope underneath and see what indeed, if there is any impacts with the glitter.
Yeah, so what I've added is just your standard craft glitter. This is the kind of stuff that you can get at your local craft store that you'll use in, when you're making cards for people or when you want to like spice up your piñata. And this is, very fine plastic glitter. And glitter historically could have been made from glass. Sometimes it's made from metal, but now it's mostly made of very small bits of colored plastic. So I've added some already to our Petri dish here. And if you look into the microscope, you'll see that a lot of this glitter is pretty small, at least to our eyes, but it's about the same size or a little bit smaller than zooplankton. All right, so what's happening here is that the bits of plastic are sticking to the carapace of the zooplankton and really impeding their ability to swim. So there have been some in-lab experiments where they take different size bits of plastic and they stick them in a tank with zooplankton to see what happens. And what we found is that plankton get trapped by microplastics. And it's not necessarily like they're stuck to the plastic forever, but anything that impedes the ability of zooplankton to swim is kind of a big deal because zooplankton don't live very long. So we need them to be able to eat and eat and eat as much as they can so they become a nutritious meal for something further up the food chain like a fish or a shark. And you can see here, this zooplankton here is unable to swim. It's got a piece of plastic lodged to its back. It's impeding really its ability to evade predators. And then the plastic makes it more visually noticeable and appealing to a predator. So it's much more likely that a predator will find it and eat it. The zooplankton cannot escape the predator, and then the predator will eat the plankton with the piece of plastic as well. And that's a pretty big concern. But one thing that we know is that plastic out in the ocean and out in the wild, it doesn't stay, in its big size. It doesn't stay the size that it is, it breaks down. So environmental factors end up not decaying, but sort of breaking into finer bits. Any piece of plastic that's out in the water.
Is that because the sun breaks it down?
Yeah, so the sun breaks it down, abrasion from things like sand or salt, just drying out from the air. Plastic, a lot of times when it's left to its own devices, becomes very brittle and it breaks up in these small pieces. So we wanted to simulate a more realistic environment for these zooplankton. So what we did is we added some glitter to the mortar and pestle, and I'm gonna grind it up here. So it's in a finer powder, which is a little bit more realistic for glitter, that's been left in the water for a couple of months or a couple of years. And I'm just gonna go ahead and add it to our zooplankton. What you're gonna see is a lot of these zooplankton make a little current around them. They have these clear carapaces, which is like their hard shell. And inside of them, you can see their legs are moving. And what their legs are doing is pulling water into their mouths and all the way down their esophagus. And in the wild, what they're aiming to do is to pull phytoplankton into their bodies, right, so they can eat. What's happening right now is that they're pulling in finely ground microplastic. So instead of eating phytoplankton, which a healthy zooplankton would do, they're eating microplastics. So anything now that eats the zooplankton will be also eating microplastics.
It's kind of amazing that all of this happens because there was a party on land with glitter, or some bottles, maybe plastic bottles rolled out of your car, and they bounced along that asphalt and little bits of it got into the pond. And now you see what happens on a micro level to the plankton.